Clampstar Deadend installation training video transmission class unit. For dead-end connections, Clampstars will provide full tension restoration and 250°C system uprating, allowing aged portions of infrastructure to be safely operated at temperatures well beyond their original design parameters. Clampstar dead-end units are available in transmission and distribution classifications, which are offered in either standard or full tension versions. Standard versions are equipped with standard torque bolts on each head, and full tension units are equipped with a combination of standard torque bolts and frusto-conical torque bolts. All Clampstar dead-end repair units will restore the conductor connector system to full tension. This installation will be done using a transmission class full tension unit. Transmission class Clampstar dead-end units are available for left or right configurations. This designation defines whether the shunt conductor is located on the left or right side of the connector. For Clampstar installations on angled dead-end towers, it is preferable to install the shunt conductor of the Clampstar to the inside of the angle such that it does not cross the tension span conductor. One side of the tower will use right-hand units and the opposite side will use left-hand units. Unless otherwise specified, Clampstar shipments containing multiple dead-end units will include 50% right-hand and 50% left-hand configurations. This concern does not apply for straight-through double dead-end towers, as either LH or RH Clampstar units may be utilized. It is recommended that equal quantities of units be maintained so that one version is not depleted when an angled tower is addressed. If conductor carts are used for maintenance and the units are installed on bundled subconductor with little to no break angle, the shunt conductors should face each other inboard of the tension span conductors to facilitate the use of a conductor cart. Therefore, a left and right unit would be paired for this application. In the event the proper version is not available, alternate installations are acceptable as long as proper workmanship procedures are employed to train the shunt conductor to assure there is no rubbing or clashing with other components. During the ordering process, one of 3 different tether brackets was selected for the intended connection configuration and subsequently provided with the Clampstar shipment. These brackets are designed to fit a variety of applications on eyes configured either vertically or horizontally. They are either a 2-bolt bracket, a 3-bolt bracket, or the quadrant tether bracket. 2-bolt brackets are used for threaded rod and fixed clevis connections. 3-bolt brackets are used for horizontal and vertical eye connections. And quadrant tether brackets are used for quadrant clamp connections. When installing the SafetyLink tether bracket on a quadrant clamp, be sure to align the bolt of the bracket perpendicular to the bottom surface of the clevis arms. The top portion of the quadrant clamp should be rotated for the most appropriate fit on the top surface of the bracket. Assemble the bracket using the nut brace and washer and hand tighten the nut, ensuring the side profile lines up properly to the quadrant clamp. This step only aligns and fits the bracket. No additional nut tightening is required. The final operation of tightening the tether will tension the bolt as well. When installing the 2-bolt universal eye bracket, position the bracket securing it with the bolts and washers. Alternate the tightening sequence in steps between bolts to achieve an evenly distributed clamp load. The recommended torque on the 3/4-inch bolt is approximately 40 foot-pounds. 3-bolt universal eye brackets are designed to be installed on either vertical or horizontal configurations. This is the proper attachment method for a 3-bolt universal eye bracket in a vertical orientation. Tighten the center bolt first and alternate the tightening sequence in the outer 2 bolts to achieve an evenly distributed clamp load. Our next installation will demonstrate the proper attachment method for a 3-bolt universal eye bracket in a horizontal orientation. As with the 3-bolt bracket vertical orientation, tighten the center bolt first and alternate the tightening sequence in the outer 2 bolts to achieve an evenly distributed clamp load. To minimize effort in the field, Clampstar units are shipped with one end of the tether cable attached to the tether tube with the tether nut completely backed off. The length of the tether nut allows the threaded end to be drawn up taut inside the tether tube and serves as a corona shield. This tether tightening process is done as the last step in the installation process. Prior to attaching the Clampstar unit to the conductor, preferably while on the ground, measure the distance from the bracket end of the tether to 2 inches beyond the end of the tension span body. Mark the tension conductor accordingly and wire brush the entire span between the marked locations to prepare for installation. The intention is to brush the conductor vigorously with a clean stainless steel wire brush to clean and roughen the surface of the conductor that will be in contact with the Clampstar connector. On the jumper conductor, mark 32 inches from the terminal connector and wire brush the conductor. Dry brushing is all that is required. Inhibitor is preloaded from the factory in the conductor grooves of the Clampstar and on the keepers as required. No other inhibitor is to be used. It's now time to attach the Clampstar tension span body onto the conductor. This is the end to which the tether is attached. Remove the zip tie that's holding the tension span head to the tension span body and slide the head out of the body. Do the same thing on the jumper side. Place the tension span body in an approximate location on the tension span conductor that will allow the tether to connect to the bracket. At the same time, place the jumper span body in its approximate location on the jumper loop conductor. Slide the tension span head, which will only start in one direction, into the tension span body until it hits the stop point. Hand tighten 1 or 2 torque limiting fasteners to temporarily hold the head in place to prevent the head from sliding out. Attach the loose end of the tether cable to the tether bracket, securing it with the supplied bolt and cotter pin. If necessary, slightly loosen the bolts on the tension span head to slide it closer to the bracket. Once the tether cable is securely fastened to the tether bracket, loosen any temporarily tightened bolts and push the tension span body away from the dead end until the tether is moderately taut before tightening any fasteners. Snug 1 or more bolts to maintain position of the unit. Transmission class Clampstar units are supplied with unique bolts designed to shear the appropriate torque level. The torque limiting bolt negates the need for a torque wrench, assures that proper fastener torque is achieved, and also provides inspectors a means to verify proper installation. To reduce installer fatigue and save a substantial amount of time, the use of power drivers, such as rattle guns or remote-controlled snake guns, are recommended. The fasteners may be tightened with either a T60 Torx or 6-spline star bit or a 3/4 inch or 19 mm socket. For full tension units, the standard bolts all tighten in multiple passes until the head shears off. Then the full tension keepers are tightened to shear in a single pass. Beginning at the outermost fastener, tighten the standard bolts in a linear fashion equivalent to the number of layers of aluminum stranding over the core. For example, assume a conductor has 3 layers of aluminum stranding over 7 steel core strands. Apply torque to each bolt in succession 2 times, with the third application of torque continuing until the head snaps off. For transmission class Clampstar units, this will occur at 55 foot-pounds of torque or 75 Newton-meters. Once all the standard bolt heads have been sheared off, remove the rubber caps and drive each of the full tension bolts to full torque, shearing the head off before continuing to the next one, progressing through all in a single pass in either direction. Repeat the process on the jumper conductor unit by sliding the head unit onto the body and tightening all the bolts with multiple passes until the torque limiting heads snap off. The safety link tether serves as a backup mechanical connection. It is not intended to be used to pull up sag in the conductor, but rather to only be tightened so it is snug, with no slack. In this manner, the original hardware cannot slip or elongate prior to overcoming the mechanical integrity of the tether. This will not require much torque on the adjustment nut. 15 to 25 foot-pounds or 20 to 30 Newton-meters of torque is sufficient. Simply tighten until the tether is straight and under some obvious tension without noticeably altering the alignment of the dead end from its original position. 15 foot-pounds of torque on the tether nut will result in 2,000 pounds of tension on the tether, which is sufficient. If a power driver is used on this operation, it will require a very light trigger finger. The tether nut can be tightened with hand tools, with the T60 bit, or using a power driver. Do not over-tighten. This dead end is now permanently corrected and corona-free through 800 kV AC and 500 kV DC.